Hi. Before we begin with this video, let me tell you that main strength of Microsoft Excel comes from its wide-ranging formula. As you can see, these formula are grouped under different categories such as financial, logical, text, date and time, lookup and reference, math and trigonometry, and many more functions such as statistical, engineering, and so on. In the next couple of videos, we shall be going through some important formula of these categories. Let's start. Now, if function is used basically when we have to carry out some test which may turn out to be true or false, and depending on the outcome of the test, we give the result as one thing or the other. Let us look at an example. For example, we are looking at deciding pass or fail depending on the percentage marks. If the percentage marks for passing is 35, then we carry out a simple test if the marks are below 35. Now, the answer to this could be true. Yes, the marks are below 35. That means the outcome of the test or outcome of this if function should be fail. And if the test is false, that means the marks are not below 35, then the outcome of the test will be false. That means the marks are not below 35. In that case, the person should be declared as pass. Okay. Now, sometimes there may not be only two outcomes. That means it's not just pass or fail. Fail is okay, below 35 is fail. Now, when a person passes, he may get 40% marks, he may get 60% marks, he may get 70 marks, or he may get 90% marks. And you may like to give a grade to him depending upon the score. For example, from 35 to below 35, okay, it's fail. But 35 to 45, you may like to give him C grade. Then 45 to 60, maybe B grade. 60 to 75, maybe A grade. And above 75, maybe A plus grade. That means the outcomes are not just two, outcomes are more than two. Okay, but the threshold for each outcome is different. We are testing for only one value. What is that? Percentage marks. But its thresholds are different. If the percentage is below 35, okay, one outcome. All right, it is not below 35. Then where? Say it is below 45, then the outcome is something else. Okay, it is not below 45. Then where? Is it below 60? Likewise, we can get different results of grades like C or B or A plus depending upon what is the percentage mark scored. So that's how we are going to take a look at these two very important functions which are used for decision making. Remember, in most of the control circuits or in most of the programs, decision making depends upon a condition. Okay, and that is where if is used. All right, let's come and take a look at the formula for if. What is the formula for if? Here we can see the formula is equal to if, and inside we write logical test. Logical test means what? You check some value for equality, for less than, for greater than, less than equal to, greater than equal to, and not equal to. Okay, so any of these things could be categorized as logical test. Okay, now the result of the test would be true or false. Okay, Excel tells the result as true or false. Now, if the result is true, then you write after placing comma, you write value if true. That means what is the answer of this formula if the test is true? And similarly, put a comma. And what is the answer of this formula if the test is false? Okay. First, let me show you how Excel shows true or false. Okay. For example, let's say I'm in this cell and I write is equal to, okay, what am I writing? Is equal to. So I'm writing a formula and I will write a simple expression. Let us say this age 45 and I will just write less than 60. Okay. That means is equal to B10 less than 60. Let me enter. It's true, right? That means when we just say B10 less than 60, it is an expression. It is an expression which uses the logical operator less than. So, because B10 value, which is 45, it is less than 60, it is giving the answer as true. Okay? It is giving the answer as true. Let's change it to 40. Is B10 less than 40? We are not written is B10, but we are just writing an expression B10 less than 40. And we are writing the formula equal to B10 less than 40. So it will be evaluated. And the answer Excel will return is either true or false. In this case, what do you expect? Is B10 less than 40? It is not. So now we are getting false over here, right? All right, let's clear it. Now that you have understood, here is a very simple example, a rule of ticket. Many a places like Disneyland or some other exhibition, some game for some child or whatever for everyone, we may have a ticket and there is a concession given for people below 8. Okay. So, what is the rule here? The ticket is 100 for everyone and 50 for others, right? Ticket is 100 for age below 8 and 50 for others. That means for 45, what is the answer you expect? The ticket should be 100, but for 6, tickets should be 50, and that's how we got. And let's take a look at the formula which is over here, okay? I'm just clicking here just to show you. What are we doing? We are checking the cell B10, which is the age. So the first condition is B10 less than 8, right? B10 less than 8 is the logical test, right? That is going to evaluate to true or false. Now, is B10 less than 8? It is not. So it is going to give us false. But next, what do you write next? Next, you write value if true. Value if true means the ticket would be 50 if it is below 8, but it is not. Okay, and so if value is false, the ticket would be 100, and rightly so. When you enter here, you can see the ticket is 100. Same way in this case, let's come to this cell. Now look at it, same formula. If is B11 below 8, yes, it is true, and hence we get the answer 50. If it was not true, we would have got 100. That's it. Simple, isn't it? All right, having seen the simple function if, which can give only two outcomes depending whether the test is true or false. Now let's move on to if else ladder where we have multiple conditions. Okay. Now what we do in multiple conditions is when, as explained earlier, when there are different outcomes expected depending upon value of one particular thing. Okay, let us take a look at it like this. Now, there is a discount being offered in a shop, let's say Bata shop. Okay, so what do they do? Now, this table looks little confusing, right? But anyway, not to get confused, from 0 to 2000, from 0 to 2000, the discount is 0. That means no discount. All right. Now, 2001 to 5000. 2001 to 5000, the discount is 20%. All right. So, and 5001 and above, the discount is 30%. Right. Is it clear? Actually, that means there are two thresholds here. If it is below 2001, that means below 2001 is what? That means 0 to 2000. What would be the answer? Answer would be 0. Okay. But If it is more than 2001, if it is 2001 and above but less than 5001, so second threshold is 5001, means it is between 2001 and 5000, and the answer to that is 0.22%. And if it is 5001 and above, then it is zero point 0.3. So I hope you have understood this particular thing. Now, having understood these things, let us take a look at the example. Here is a bill amount 6,000, 1,500, and 14,000, and we want to know what would be the discount, right? So let us see what is the formula used in this cell. I'm going to click here so that it will highlight the cells, right? See, it has highlighted two thresholds. 2001 is one threshold and 5001 is another threshold. That means if it is below 2001, then the discount is going to be zero. So that is what it says here. If E9 is less than B11, okay, B11, what is B11? B11 is nothing but 2001, okay. B11 is 2001, all right. If it is less than that, then value if true, it is zero, right? Value if true is zero, okay. Now, if it is not below 2001, what could be the answer? There is no one answer because there are multiple answers here. We would like to further check whether it is below 5001 or not. So we use nested if. So in the position of false for the first outer if, we put another if. That means it is not below 2001. Okay, then check further. That means it has come to false. So check further. Okay, is it below 5001? So is E9 less than B12? Okay, is it less than B12? That means is it less than 5001? If it is so, that means it is between 2001 and 5000, and rightfully the discount would be 0.2. Okay, what if it is not below 5001? That means it 5001, 5000. That means it is more than 5001 or more, and the discount would come here in value. If false place, it is zero point 0.3, right? So this particular if formula, including a nested if formula, okay, is going to give the answer of what, whether the discount is going to be 0 or zero point 0.2 or zero point 0.3, and to get the actual discount amount we multiply it by E9, so into E9, and that would give us the result 1800, right? So 6,000, as you can see clearly, is more than 5,000, so we get 30% discount. 30% of 6,000 is 1800. Look here, 1,500 is below 2,000, so no discount, so discount amount is 0. 4,000 is between 2,000 and 5,000, 2001 and 5,000, so rightly it should be 20%, so 20% of 4,000 is 800. That's it, and net bill is nothing but bill amount minus discount, and that's how we got the answer, right? Now, one hint I'm going to give here, very important thing. Generally, the bill amount in such cases will be worked out for large number of figures, okay, and also there should be a flexibility to change the values of discount, okay. For example, Bata shop might offer 20% and 30% during a season, let's say Christmas or New Year or Diwali or whatever. Otherwise, they might offer some discount still. They might offer 10% and 20%. Now, what do we do? We can't keep changing the thing over here in the formula, right? So value written in the formula should be same. So if we write these zero point 0.2 and zero point 0.3 figures, if we write this zero point 0.2 and zero point 0.3 figures, like we have written here, like we have written here, zero point 0.2, okay, zero point 0.2 and zero point 0.3 and 0. So these are hard coded. So these values you can't change. Instead of that, since they are tabulated in this rule for discount 0, zero point 0.2 and zero point 0.3, why not write the actual cell reference over there? And once having done that, here is the actual formula, better improvised formula you can see. All right, here I put the improvised formula, and now you can see it is highlighting all the cells. Why? Because instead of hard coding these values point 0, point 2, and point 3, we have given the cell references. Like you can see here, B11, okay, and then we have given C10, and then we have given B12 and C11 and C12, okay, right? So have you noticed that I have put $C $10 and $B $12 and $C $11? It might just about look confusing, but we have already gone through and seen this particular type of notation. What does it indicate? It indicates an absolute reference. Okay, for those of you who haven't gone through my previous video on absolute reference, please do go through absolute reference, and you will find that $B $12, it means an absolute reference. So when we drag this formula down for different cells, the value of this 0, point 0.2 and zero point 0.3 does not come down and change, it remains fixed. And therefore, these figures 2001, 5001, 0, 2, and 3 are given by using absolute reference. That's how you can see $B $11, C $10, and so on. All right. One last hint before we end the video. It is extremely important in a nested if ladder that the values in the rule table, they are in ascending order. That means what? So we cannot write for 0 the discount is 0, and then 5,000 the discount is 30%, and 2,000 the discount, it will go wrong. So from 0 it would exceed and reach up to 2,000. From 2001 it would exceed and reach up to 5,000. And please, in this ascending order only you must write this, then only it will work, otherwise it will give wrong results. That's it. It's pretty useful, isn't it? And not very difficult as yet. Okay, bye and see you in the next video. And yes, if you find this useful, click the like. If you wish to catch several such videos, hit subscribe. For notifications, ring the bell and share this so that others too can watch. Bye.